I'm going to show you how to build a booking system that handles customer inquiries automatically via SMS. And more importantly, that is 100% reliable. By the end of this video, you'll understand every component that makes this automation bulletproof. The system that we are looking at handles photography services requests entirely through SMS. When a customer texts us asking for photography services, the system will filter out spam and irrelevant messages, extract key booking information like dates, locations, and service requirements, manage the entire booking lifecycle, from initial inquiry to confirm booking, provide intelligent responses and ask for missing information, and finally, escalate to human agents when required. The system achieves 100% reliability following a core principle. Use deterministic code wherever possible and only delegate to AI agents what cannot be done deterministically. Before we dive deep into the technical details, if you're looking to integrate this kind of automation into your business, this is what we do at Flowhog.com. We help companies scale their systems using AI. From booking systems like the one you are seeing in this video to customer support automation, lead qualification, and more complex workflow orchestration. We create custom solutions that integrate within your existing tools and that help you scale your business. If you want to discuss how you can automate your specific business processes, reach out to me either directly or through flowhog.com and we'll be happy to help you. Now, let's get to the technical details. Here we have the diagram of the infrastructure that we are going to be building today. First of all, I'm going to walk you through the different parts of the system, and afterwards, I'm going to explain you the advantages of using these systems. The flow starts with an incoming SMS. And here we need to use an external service that allows us to have a number and then use an API to retrieve incoming SMS and also to create outgoing SMS. In this example, we are going to use JustCall, the data service that provides this functionality. Once we receive the incoming SMS, this is where our custom system comes into place. We are going to have a server and we are going to be building the server using the FastAPI framework. And then we are going to use another service called Celery. This service, what is going to allow us is to create queue system, that it's called, that basically for each request that we get in our server, we're going to create a task behind the scenes. And then a separate service is going to be responsible of taking these tasks and executing some workflow. And this is very important in order to build a system that can scale. So you want to decouple the server that it's getting the requests from clients from the service that is actually taking these requests and doing some job. And this is the magic of Celery. It allows us to both create the system queue, but also create some workers that are fully decoupled from our FastAPI application to perform the tasks. In order for Celery to work, we need an external database where Celery will be posting the tasks to be done, and then the workers of Celery will be updating the status of this task. We are going to be using Redis because it's the most used database for this queue system. So here at the right of the screen, we have the task that each Celery worker is going to handle. So when there's a new incoming SMS, we will register the task, and then this worker of Celery will take the task and will perform the following workflow. And this is the core workflow that we have in our system and that will be responsible for taking the SMS, processing the information, updating our database according to the information received, and finally generating the final reply that will be sent to our client. And here is where we will be using a different set of AI agents that will be responsible for executing a particular task in the workflow. Here I'm going to give you another insight, and is that you want to avoid using as much as possible AI agents. Why I'm saying this? Because AI agents are not deterministic. They behave different each time they are executing, and the most robust systems are those that are fully deterministic. And actually, the systems that real companies are deploying to production and that are working, they try to use as much as possible static code and only use AI agents in those parts of the system where using static code is not as good as using the agent. All right. So keep this in mind when you're building a system. Try to build it using a static code. If at some point you need to have some capability that with static code you are not able to achieve, like natural language processing or this kind of tasks, this is where you should be using AI agents. So this is what we are doing here. For each SMS that we receive, we're going to use a first AI agent that is going to decide whether this SMS is spam or not. So this way we can filter out those SMS that we are not interested in. Then we are going to use a second agent that will be responsible for extracting the required information that we need to process our booking. And now that we have all this information and that we are sure that this SMS is not a spam message, this is where we are going to use static code to retrieve some information from our database, perform some operations like updating the database with the new information extracted from the message, and then deciding the status of the job. And as I was saying, this is a core logic that you definitely do not want to delegate to an AI agent. This logic should be fully deterministic. You want to understand 100% of the times why the system is behaving in one way or another. So the core business logic should be done using static code, okay? I hope it's clear. All right, so here we are using the Postgres database to store the information of our client bookings. And after having updated all this information, having decided whether the booking is ready to be published or there's still some missing information, this is where we go to the second agent. We pass all this information to the agent. We're going to explain him whether the booking is ready to be published or if there's still missing information. We are going to let him generate a reply. Let's skip for now these sections of the tool and let's go to the last part of the flow. And this is once we have the reply of the agent, then we are going to use again static code to trigger the SMS notification that our client will receive. Let's forget for a moment about this section of tools and let's get to the last step of the flow. And this is where, again, using static code, we are going to generate the final reply and we're going to trigger the SMS notification that our client will receive. Again, this triggering of this notification will be using static code. The reason for using static code here is to reduce the risk of the system behaving unexpectedly. We want to make sure that the same client that has sent us the SMS is the one receiving the information. Therefore, we do not want to give that flexibility to the agent so that he can decide what's the number that should receive the message. Let's get now to understand the different tools that our AI agent is using. First of all, this third AI agent, it's the only one that has tools at its disposal, okay? Try to build agents that are as simple as possible, and only when it's strictly required to use tools and more agentic stuff, just do it. So in our case, we'll have two tools for this agent. The first tool will send the message to our human that will be responsible to handle all those queries that cannot be handled by our system. And the second tool, it will allow the agent to publish the job once it has received all the different details that we require for our booking and that the client has confirmed that these details are correct. Basically, our agent will be able to publish this booking in an internal Telegram group where we'll have different photographers and these photographers will be able to apply. So in the end, we want to give here the agent the ability to decide when something happens, when a message has to be escalated, when a job has to be published, but inside these tools, we are going to have some safety mechanisms in case the agent calls these tools whenever it's not required to just skip the execution. So after having seen the infrastructure, maybe you are thinking, man, why do I need to build such a complex thing? Why not using a no-code tool like NA10 or Zapier and make it easier? And the reason is because these tools will not work on production. What happens? These systems provide you two main advantages that you would not have in NA10 or Zapier. First of all, it's a matter of scalability. So by allowing to decouple the server that is receiving requests from the execution of the workflow, you have a way to receive multiple requests, let's say hundreds or even thousands per minute, without the system falling apart. So if you're using NA10, for each request that you receive, you execute the workflow at the same time. So if you get to a point that you are receiving multiple requests at the same time, the system will not work because it will not be able to handle the new incoming requests. And it's true that they have some sort of mechanism in place, that they have some scalability, but it's quite limited in comparison to this system. And there's another thing that it's about building a system that is able to have some kind of knowledge about the different tasks that are being executed. So what happens? Imagine that you are talking with a client in SMS, and the client sends 2 messages, one immediately after the other. With these systems, what you're able to do is, first of all, when the first SMS is received, you can schedule the task to be executed, let's say 15 seconds from now, and once the second message is received, you can cancel the first task and then execute the workflow considering the 2 messages. So you have a mechanism there that it's very useful in these scenarios because it happens all the time when you're building a chat system that the client sends 2, 3, 4, or 5 messages one after each other, and you need to have some buffer of seconds before processing all of them. With this system like Celery, you're able to schedule and cancel tasks. In Editor or Sapien, what will happen is that you will trigger the execution for each of these messages, and this will result in, first of all, wasting resources, but secondly, you would send to the client 5 different messages, and this will give a very poor experience for the end client, okay? And coming to this second point of system quality, one of the big disadvantages of using a no-code tool is that you don't have a way to modify the system in a reliable way. Why I'm saying this? At some point, you will need to start increasing the complexity of the system because there will be many edge cases. So imagine this scenario. We are in this system that we are asking for information to create a booking for a photographer service, and you have many services available, okay? The thing is that some services require additional information, but others don't. So what happens? Here you have to start building very custom logic that at some point will require modify the business logic, okay? If you try to build these systems in a no-code tool, you don't have a way to being sure that by modifying these different boxes, you are not breaking some behavior that before was working. And here, you have to forgive me for getting a bit more technical, but by having this piece of code here that it's deterministic and that allows you to handle the different business logic, you can build this using a methodology called test-driven development. That it's basically you create the different scenarios that you want the system to follow. And whenever you are modifying the code, you are 100% sure that the system is still succeeding at those scenarios, or you can immediately see if they are falling, okay? And with this, rectify the code. So at the end of the day, you have some reliability and you can be 100% sure that the system you are building is going to work now, but it's also going to work in the future once you keep adding more scenarios. Perfect. So in this section, I'm going to walk you through the code so you can use it yourself and also you can understand how it is working. So just before we start, make sure you pull the repo that it will be in the description. Let's start with how the SMS enter our system. We will need to set up some configuration in the Just Call platform so that the platform is forwarding the SMS notifications to our server. We'll do this later, but in this code, I'm going to show you how you can create the server and how you can define the endpoint that the Just Call platform will call. This is done in the main PI file. So in this file here, we are creating the server. So we are using FastAPI, and we are initializing some services that we will be later using in our application. These services are the Redis service, so we can use Celery to store the different tasks in this database. And then we are going to initialize the Celery service. That is this library that allows us to create this queue system to asynchronously handle tasks for each SMS that we receive. If we go to the API folder under routes, this is where we define the endpoints. This is the public endpoints that will be available so that the Just Call platform can call. And here actually we only have one endpoint. This is the SMS, okay? And it's a very straightforward endpoint. We just take the data from the request, following the format that JustCall uses to communicate with us. And we just create a task using the Celery service, okay? The task is going to be SMS processing, and we are using this function queue SMS processing the bounds to create a task in the queue. So then a worker from Celery, that it's a separate service, can take this task and process it. Let's get now to see the Celery service. And as I said, this is where the real power of our system lies. So our system is able to handle multiple concurrent requests at the same time without facing race conditions and making sure that each SMS that it's processed has his own isolated pipeline. And this is done in this file. Basically, we define this Celery service. We are going to call it photography booking processor. We define some parameters. And here, the most important part are these tasks that we are defining inside this file. We have one task that it's called process incoming SMS task. And then we have a second task that is called publish job task. For the process incoming SMS task, this is where the logic that we saw in our diagram on the right, it's defined. Okay, so when the task is executed, it means that this function will be run. We'll later get into inside this logic that process incoming SMS, but as of now, you just need to understand this. Here in this file, we define the different tasks that can be executed by our Celery workers. And then we have a second task that actually I haven't talked about it in our diagram, but when the agent decides to publish the job, this is also executed asynchronously. So we have a specific task for this job of publishing the booking in our Telegram groups. So in the end, what will happen is we'll create one task inside Celery that at the same time, while it's being executed, it will create a second task. And once our worker finishes to execute the first task, it will continue and then process the second task that it's out publishing the job. Again, here we have some custom logic where we use some services to connect to our database, we initialize the Telegram service so that we can send this job to our groups. And here we have some custom logic that is about creating the message in the format that we want. Okay, and that's it. Once we have this, we send the message and then we update our database. Just before we proceed, I want to mention briefly a bit the Celery app configuration. One important parameter is this one, worker concurrency, that this allows us to set up how many workers we want to have processing the different tasks. This means that if you have multiple workers, a task will be executed before a previous task is finished. For this particular scenario, it's fine to have multiple ones, but there are some cases where you want to have only one. I don't want to add too much in detail into this because it's a bit technical, but I just want you to know about the existence of this parameter and also about the task routes. This is where we define the different queues that we have, and later we will be able to reference these queues to assign a worker to one of these queues. In any case, in this file, as we have seen, we have defined our Celery app, the different tasks that we have, the behavior, like how many workers, etc. But somehow we need a service that allows us to put some tasks inside the queues that we have defined here. Because as you saw in the FastAPI routes, we have a function here that it's called queue SMS processing the bounds. Actually, this service, we can find it inside Celery service. So this is a class that basically is taking our Celery app. Okay, as you see, we are importing it from the file that we have here, the Celery app 1. And we are defining some functions that allow us to put these different tasks in the queue. So we have one task for queue SMS processing the bounds. And here we are using a Celery function that allows us to not queue the task immediately, but wait some seconds. This is this task that it's called applies async, and it has a countdown. As I said, this is some functions that are already defined inside Celery. And this is the magic of these libraries. Like, they have these functionalities already implemented and they are already battle tested. So we just have to take the library and understand how it works, and then we can use it in our code. Okay. The reason why we want to have some delay when queuing tasks is because of the nature of the chat interactions. That basically clients, instead of sending all the information in one message, they can send you different messages at a time. So you want to give a grace period, let's say, before we start processing these interactions. So here what we are going to do is we're going to wait around 22 seconds before processing the task. And in this time lapse of 22 seconds, if we receive another message, we're going to kill the task and we are going to schedule a new one in the next 22 seconds. And this is an endless loop. If after scheduling the second task, we get a new message within 22 seconds, we will again kill the new task and create a new one. So this way we make sure that we are only going to reply to our client 22 seconds after the last message he has sent. And the same for queue publish job. As we saw, we have one task that is about publishing a job. Here we are defining a function that allows us to put this task in the queue. And this is quite simple. We just call the publish job task, and that's it. All right, so now we explain a bit how Celery works. But if you remember in our diagram, we saw that Celery it's heavily connected to Redis, okay? Because it uses Redis to store the different tasks that have to be processed, and also to store the status of these tasks, where they are still pending, and once they have been processed, the status is updated. And this is going to be done using the Redis service that we have defined here. So in this class over here, we're creating Redis instance using the Redis library. And then we are creating some functions that allow us to get some information from the database, setting some values in the database, deleting values, creating timeouts for the different keys. This is also a bit technical and it's more about Redis way of working, but you can have a further look on the documentation about Redis. Okay, as you saw in the Celery app, actually, here we are defining a broker URL and a result backend URL. That this is the Redis instance that we are going to use to store the tasks and also to store the result once these tasks have finished. Another thing we have to consider is that in our Celery service, as I was explaining, we have a 22 seconds delay before processing a task, and during these 22 seconds we check whether we have some tasks pending to be executed. And in order to build this logic, this is done using Redis. Whenever we receive a new SMS, we are creating a task ID for the task that we are going to store in Celery, and we are going to give an expiration of these delay seconds. Actually, it's here. We are using the Redis service that we just saw. We create a value with the task ID and we create some delay, okay? And then here, when in this first if statement, what we are doing is we are trying to retrieve the task ID for the SMS processed, and if we find that this task is already in the database, we are going to kill the task from our queue. So this way what we are doing is we are recording in our database a task ID during 22 seconds. If in the next 22 seconds we receive a new request, we are going to detect that this task that is already in the DB has been there for less than 22 seconds, so we have to cancel it. And otherwise, if 22 seconds go by, Redis will automatically delete this information from our database. This is what allows us this parameter here called X. This is one of the nicest things of using Redis, that it has this caching capability that allows us to quickly store information in our database, quickly retrieve it, and also to treat this information as a temporary information that can be removed within short periods of time. So now we saw FastAPI, we saw Celery, We saw how Redis is connected to Celery, and now it's time to get to the core logic of the project, to see the business logic that we have defined. If we go to our Celery app, where we defined the task that has to be executed, that it's called process incoming SMS, here we are seeing that inside this task, we have this function called process incoming SMS, where we are sending database connection, we are providing a just call service, a Telegram service, the number that we received the SMS from, and the message. And then inside this function over here, we are going to execute the full workflow that we saw. We are going to run the SMS agent, we are going to execute the filter agent to filter out those SMS that are spam. We're going to run the info collector agent to make sure we extract the information that we want from the message we received. We are going to update our database according to this information. Then we are going to pass this information to the SMS reply agent so it can generate a reply, and in case the client has asked some stuff that it's not that easy to reply, it will be able to escalate, etc. And finally, we are going to reply back to our customer using the just call service. So all this logic is basically done here. Okay, so we have this function, process incoming SMS. We take the number, we are going to run, we take the number that we have received. We are going to normalize it because we want to make sure that we follow a consistency. We want all numbers to be stored in the database without the plus prefix. We want to also have the country code. Okay, and this is done in this function over here, normalize phone number, that we have in the utils function. I will not get into, we can actually see it quickly, but yeah, it's quite easy. We just take the number and clean it. Okay, so here you have some examples of what would be the and here you have some examples. In any case, let's go back to our SMS workflow. And yeah, so we have the number. We try to build the conversation history. And actually here we are using just call service. Okay, the just call service, it's another service that we have defined ourselves, and it's actually here. And again, it's just a Python class that it's an abstraction of all the different API calls that you can use in just call, but adapting them to our needs. Okay, so this way, here we can define the logic that we want to have in just call, and in our application, we just need to use this service. Okay, this is a way of separating concerns. Okay, you want to have a code that is very modular, so whenever you want to modify something, it's completely isolated from the other parts of your code. And here we have defined a function that is called send SMS, where basically we just pass the number and the message, and here we are using the just call API to use it. We have also send MMS, we have also send MMS, that is a multimedia message that is going to allow us to send some images about the services that we have, that actually it's inside this. If we go inside asset services, here we have this is the infographics of our services, and actually we have uploaded this file into our cloud, and here we are calling this URL that consists on this file. So we are not actually loading this statically, we are just taking this file from our cloud. Finally, we have this get conversation history function that is just taking a number, and from this number we are going to retrieve the last 10 messages that we have in just call. So here we have built a logic where we use some functions that just call provides, and we are converting the different messages into a format that we want to use in our app. So we are going to follow this chat completions API format where we have a role and content format. In any case, let's go back to the SMS workflow. Here we are calling the just call service to get the conversation. We are just making sure the conversation it's containing one string. Finally, we are getting information from this existing client by calling this function that accepts a phone number. And here we are entering into another part of our code base, that is the repositories folder. So the repositories folders are a different set of files that allow us to interact with our database, and more particular with a specific table in our database, and retrieve the information that we want and also update the information that we want. So in our case, we have 3 services, one for the clients that allow us to update and create a client and get some jobs. That a job would be bookings from our clients, information related to the job, that is the bookings. We can get the ID of the booking, create a new booking, update, etc. And the same for services. So in our database, we have a service table that contains the different services with the different prices and names that we have. And actually, you can see the database here. If you go inside DB Migrations initial schema, this is the schema that we have for our database. We have a table clients, we have a table called job services, we have a table jobs, and we have a table services. So job services, basically it's a way of linking a specific booking with the different services that we have, that we can provide. So actually here, in this SQL statement, we are inserting different services in our database. All right, so let's go back to the SMS workflow. And going back to this get by phone repository call, here we just get the client. If it exists, we are storing here. If it doesn't exist, we are going to have to create a new one. Here, if it's an existing client that it's already in our database, we are going to assume that it's not going to send us spam messages. On the other hand, if it's the first time that this client is contacting us and his information is not on the database, we're going to use this SMS filter agent to make sure that this person is not sending us spam. And here we get into this part of our code where we define our agents. This is inside agents folder. So here we have one file per agent. And if we go to this file, SMS filter, this is the agent that we have defined to filter our messages. We are using the Pydantic AI framework to define the agent. I will link in the video another video where I cover how to build agents using Pydantic AI. But here, the most important thing is that we are telling the agent to provide as output a Boolean. So we are going to expect an object that has as key is service request. And if it's a service request, the agent is going to return us true. Here we will need to do some assessment of the agent, testing with different conversations to make sure it filters the one we want. Let's go back to our SMS workflow. So we detect whether it's an SMS request or not. If it's not a service request, we are going to just skip the process. We are not going to waste resources, and we are not going to create some bookings in our database for an SMS that it's a spam, all right? But if it's not a spam message and it means that the conversation potentially has some booking information, we are going to run our second agent. This is the info collector agent. That if we go here, again, we are using Pydantic AI to define the agent. Here we are creating the prompt where we explain all the different informations that we want to collect, and we provide an example. Something very important that it's key to make the system work, it's to force the agent to output his response in a specific format. This is service request info. And here in service request info, we are setting the different fields that we want to collect. Client name, last name, email, date, start time, number of guests, the event type, the number of photographers that he wants to book. And here, as you see, we have some different types that we have defined over here. We have a service code for the different services, and we have an event type for the different events that our photographers can assist. So what is going to happen is the agent will receive a message. It will try to collect this information, but then it will make sure that all this information follow the format that we want. So for the services, we always expect a list of service codes. So the agent has to provide always the services codes that we have here. It cannot invent other services, because if it does, the framework itself will ask the agent to try again to generate the output until the agent is able to generate the output that we want. All right, and that's it. We are receiving the information. And now we get to one of the most important parts in the flow. And this is the deterministic code that allows us to get some information, update information in the DB about the booking, update information about the client, updating the status of the booking, etc. And this is done in this function over here. We take some service information, and here, this is a very complex flow that actually what you would like to do is to create some unit tests for this file so you are sure that it behaves the way you want. So potentially, if you need to modify this in the future because you want to include newer edge cases and newer scenarios, you are totally sure that by modifying the code, you will not break it. If you want, I can create a new video for this, but this would be a complete different topic. What I can say is that this function was coded using test-driven development, and I totally encourage you to develop using this way of coding because it's super powerful. But let's have a look. Basically, we're taking the service information. We are trying to get information from our database about the job, if we're able to get the ID. If not, we are trying to get the booking ID from our existing clients in our database. So basically, if we don't have the booking ID, we try to get the client using his phone or email. And from there, we are trying to get the different jobs assigned to this client. Then we're going to update the job. So we are getting the job status. If it's not on pending client info or ready to post, we are going to skip it. And here we are going to get the client itself, and we are going to either create the client if it's not on the database, or we are going to update the information that we have in the database from the client. So imagine that in the beginning, the client said that his name was John, but it has a typo. And then in a second message, the client asks to change the name. This way we're able to update it. Here we create the booking or update it in case it's not created. And finally, here we have a function that allows us to convert the different service codes that our agent has extracted to service IDs that we have in our database. This is just a database logic, but that's it. All right, so the next step of the workflow is that the SMS replier agent should take all this information that we have from our client and the booking and then generate a reply. And actually, this is done over here. We have this function that it's called getConsolidatedView that basically it's mixing the table of clients and the table of services and job services to get the full picture of this client. So now we're going to use this getConsolidatedView function to get all the information that we have from our client and its booking. We are going to detect whether the client has provided all the information and if it still has to provide us more information. So if it's the first case that it has provided all information and the job status is on ready to post, we are going to provide to our SMS replier agent the information and we are going to ask him to confirm the job details with the client. On the other hand, if we detect that the job is on pending client info, we're going to collect the different fields that are missing and we are going to provide those to the SMS replier so that it can create a text asking the client to provide this information. If we go to this part over here, we are running this SMS replier agent and we are providing a lot of dependencies. We are providing the job ID, the job status, job details, missing information, and then we are going to dynamically insert this into the prompt of the agent so it has all the picture. And just before we get into the SMS replier agent, as you have seen, I have skipped one step here that actually it's very important because it really provides a lot of value on the system. And this is this just call service escalation tag ID. We are using this platform called just call to retrieve the different messages. And something very nice about this platform is that it has a dashboard that we can use to not only see what's going on with different messages that are being sent by our automation, but also to reply to our clients live. We're going to play with some tags that this platform allows in the different conversations. So whenever our agent detects that something goes wrong and we have to escalate this to a human, we're going to tag our conversation on just call with this tag. So this way, the human that is behind the scenes handling all these requests knows visually what are the different conversations that it has to take. But then in our automation, we have also incorporated this step that checks if a conversation is already escalated. Basically, we're going to check the tag, and if it contains the tag escalation, we're going to skip this last part about sending the message to the client. So this way, we're totally sure that our automation is paused and it's not replying again. Let's have a look at the SMS reply agent that is inside the agents folder. This is the most complex agent that we have built. First of all, as you see, it has a full prompt that it's explaining its task. It's setting some behavior, like we don't want the agent to invent, hallucinate, etc. We're also explaining him how it should behave on the different scenarios. So for example, if the job status is in pending client info, we're going to prompt the agent to ask for the missing information to complete the booking. On the other hand, if the job is already to post, we're going to ask the agent to wait for the client to provide a clear confirmation that the job details are correct. And if this happens, we are going to ask him to call the confirm service request tool. We'll later see this tool. You can get the idea. Here you define all the logic of the agent, like how it should reply, but also how it should behave, when it should call one tool or the other. The same with the second tool, that it's escalate request tool. So we are telling the agent that whenever the client is asking complex questions, it should escalate the matter to a human, and it should use the escalate request tool. Here it's the same logic that we followed before. We define the agent, we define the instructions. Here we are not defining an expected output type because we want the output to be a response. We want it to be a string. And so actually this services scenario should be removed. And here we are defining the different dependencies that our agent requires to perform his task. Bear with me, and now you'll see how these dependencies are integrated into the agent. First of all, we use this decorator function to dynamically add another part to the prompt. This is some Pydantic AI functionality that allows you to do this. We're going to take the job status and we're going to append it to the prompt. So as you see, from the context, the dependencies, we're going to take the job status defined here and the job ID. Then, depending on the status, whether it's pending client info or ready to post, we're going to add a different prompt to our original prompt. So if it's pending client info, we're going to add all the missing booking information that these fields also have been passed as a dependency, and they have been retrieved in the SMS workflow logic. On the other hand, if it's the job is already ready to post and we just need to get the confirmation from the client, we're going to add this part to this prompt. That basically we're using this function that takes the different fields and it creates a nice string with all the information, like event type, number of photographers with the values, etc. All right, so this is how we define dynamically a prompt in Pydantic AI. And now let's go to the tools. In my original diagram, I only had 2 tools, but actually this agent has 3 tools. It has one tool to escalate a request, a second tool to confirm the service request, and a third tool to send the image with the services whenever the client is asking explicitly for these services. In the first one, to escalate a request to a human, we're going to use the Telegram service that we are passing as a dependency. We're going to send a message to this chat ID, and we are going to send this information. We're going to tell our human, hey, there has been something going on with this phone number, and the issue has been this one. So here we're explaining the agent that when it calls this tool, it should provide a short message explaining why it has decided to escalate this information. And this is going to be very useful because then in our Telegram, we're going to see in the message not only the request, like the client that is having some issues, but we are going to see what issue has happened for the request to be escalated. And something that we are going to do here is to tag in our just call dashboard this conversation as escalated, so then our human knows that conversation should be treated, and also in case our client send us another message before our human is able to take this conversation, we post the automation and we do not trigger it. All right, so this is how we escalate. Then to confirm the service request, we're going to call this confirm job application that actually, if you go there, this is a function that what it's doing, it's basically going to check that the job ID is on ready to post. And if that's the case, it's going to, here we are going to format a bit the date, but then here we are creating a code. We are going to take the date of the event and also the first name of the client to create a job code that later we'll be publishing in our Telegram group, so then the photographers can apply it to this job code. This is just secondary logic, but the most important part is here, QJob publication. So here in QJob publication, we see that we are using this Celery service, and inside the Celery service, we are using the function to queue the job. All right, so this is how our agent can confirm a service request and publish this information in a Telegram. So now the third and last tool that our agent has, it's this one that allows the agent to send an SMS message to our client with the service information. Here we are doing some logic to get this image path, and we are calling the just call service send multimedia message. And something that is crucial here is that this phone number, you should never let the agent decide this number. As you see, this phone number is taken from a dependency, that this is the done here. And actually this dependency, if we go in the SMS workflow, so here is where we are running the agent. Here we are passing these dependencies. And as phone number, we are getting this normalized from number that actually it's taken from the from number that was passed when calling the process incoming SMS. That actually, this is the phone number that we are retrieving from the just call request. So this is super important because this way we totally reduce the risk of the agent sending messages to unwanted numbers and also to prevent attacks. If you don't pass this field as a dependency and you allow the agent to set this number field as a parameter, some bad actor could force the agent to send a random message to a random number, and you should definitely do not want to do this. If we go back to our flow, the last part, it's just taking the response of the SMS replier and then using the just call service to generate the message. And again, this is a static code. We pass some parameters, like the number where we are going to send the message, it's the same that triggered this task, and the information, like the reply text, is the one that our agent has provided us. So again, here we make sure that the same client that has texted us is the one that is going to receive the message. All right, now it's time for the demo. So if you go to this README file over here, you will find the different steps that you have to follow to get the system up and running. Still, I will just follow these steps right now so you can follow them with me. And yeah, the first thing we need to do is we have to go to our M file, and inside the .m file, we'll have to put our just call settings and also our Telegram settings. So let's first start with just call. If you go to the just call dashboard, when you open an account, you will find something like this. So now you have to go here to the top right corner, then under APIs and webhooks, and copy this API key and API secret. And once you have these values, go back to your end file and paste them here, API key and API secret. The next thing we have to do is to get the just call number, just call phone ID, and also to create an escalation tag ID that later we will be using to tag our conversations whenever there's an issue and we have to escalate that conversation to our human agent. So if you are here in the same page, just click on Access Developer Documentation, go to the API reference, and under SMS, go to Create a Tag. And the first thing you need to do is to put your authorization credentials. So here in the header, paste your API key followed by these two dots and then the API secret. And with this now, you are able to run some API calls while being authorized. Now if here we just create a tag, I will not do it because I've already done it, but just make sure that you put here escalated. Yeah, like that. Just put a color code, and once you run this API call, you will get a message like this. And here you have to take this ID. And with this ID, just go back to the M file and paste it here under just call escalation tag ID. Let's try to take the just call number and phone ID. To this, go to phone numbers, list all phone numbers, and here just run it again. You get a response like this. Make sure that you take this ID and then the just call number. And these two values, you'll have to paste them here under just call number and just call phone ID. And that's it for just call. Now let's see how we can get the Telegram bot token and Telegram target chat IDs. So in our system, we'll use Telegram both to receive escalation messages and also to publish the different booking requests in our different chats where we have our photographers. So to get the Telegram bot token, go to Telegram. You will have to talk to BotFather. That BotFather is this default bot that allows you to create new bots. Just type new bot, and here you have to give some name, some username, etc. And at some point, BotFather will provide a bot token that you will need to paste it in the code under Telegram bot token. For the Telegram target chat IDs, we are sending the escalation messages to the same person that is receiving the booking request. But normally what you would do is you would modify a bit the code, and you would have on one side a chat ID where you will send escalation messages, and then an array of chat IDs where you will send the different jobs. Still here, I will be using my personal account. So here I'm in Telegram. For now, just ignore these messages. These are the type of messages that we will receive whenever there has been some escalation. So now here, just type something. And once you type this, just go to the README file. Take this URL here, just replace your bot token with the one that you actually have. And once you paste this in a browser, you will receive a JSON message, and there you will have to take the chat ID. Once you take the chat ID, just paste it here. And with this, everything is set up. If we have a look at the README, the next thing we have to do is to set up ngrok. So ngrok allows us to make our application publicly available. So now we can run it, and it will be running in our desktop, but we need somehow a way to allow just call to send the notifications whenever a new SMS is received to our local system. Just go to ngrok, create an account. Once you create an account, you will be able to have a static domain. So each time that you run your command on your terminal, you will always expose your local host to the same domain. Okay, this will allow you to set up one domain in your just call, and you will not have to modify it again. All right, so with this, just create an account and just run this command over here. This one, grok http, and here you have to replace your domain. And now I will run it with my own domain. Give me 1 second. Now I just run it, and I have ngrok running under this domain. And actually, all the requests that are received in this domain will be redirected to our local host in the port 8080. So with this, now we have to go to just call and tell just call to send anytime there's a notification when an SMS is received to this endpoint, actually to this domain /SMS. This is where we created our endpoint over here. You see it. So let's go there. Just call, and here go to hook settings, and under webhook settings, go to SMS received, and here paste your URL /SMS. And just click on save. Now we completed step 5, and we go to the last step, that is running the application. We just take this command, docker compose appd, and paste it. Before we run it, make sure that you have Docker Desktop downloaded and it's running. So regarding Docker, I will not explain too much in detail what Docker is about and how it works, because there are plenty of tutorials out there that are very good, and also it's a very extensive topic. So actually, if you are interested about how to properly create systems that can run in production and that are reliable, that you can have some kind of monitoring and that you can scale, Docker is the way to go, because it allows you to isolate the different parts of your system into microservices, and it makes way easier to maintain these services. In any case, if you go to Docker Compose file, Here you will see the different services that you are going to run once you execute this command. You will create a Postgres database, and during initialization you will run these SQL codes over here that will create the different tables. Here you will create a Redis database. You will create the app. It's this FastAPI service that you have created. Create a Celery worker, that it's this worker that will take the tasks of Celery and will execute them. As said, this is just a very high level overview, and likely you would require more knowledge on how to properly build this system. So let me know if you are interested to know more about Docker, and maybe I can create a tutorial. But in any case, for the sake of this demo, let's just assume that this is going to work, and let's run this command here. Now make sure that you are under this SMS booking automation, and now just run the command. And here the different services are being started and created healthy. So actually now if we run docker compose logs, here we are going to see the logs of our system. Let's do something. Let's stop Docker. And now let's run it again, but without this -d. And now we'll receive live the different logs. So you see here, Redis is started, Postgres is started, and our app, that is this FastAPI server, has properly been initialized. All right, so that's it. With this, now we can proceed and try to send some messages to our just call phone number and see if the automation is running. Let's go to just call. So we are in this dashboard that allows us to see the different conversations we have had with different phone numbers. In this demo, I'm going to use my personal number. So what you're going to see is that I will send messages with my phone, and you will see them live in the dashboard. And what we expect is that every time we receive an SMS, something is going on. The automation is triggered, and the agent processes the SMS, and we have a message back. Just ignore these messages here that I've sent before. Actually, let's delete these ones, and it's going to be easier. Maybe we can delete them. Yeah. All right, so I just sent this message, and you see it. Hi, I want to book some photography for my wedding. And if we go to our code, all right, here what we see is that we have received a post request, and that a task has been created. And now it's being executed, processing incoming SMS. All right, and here if we refresh, the automation is asking us for different fields that we need to complete the booking. And here I'm going to text again. And actually, I have asked about what services do they offer. And then theoretically, the agent should provide us the services. Oh, sorry, here you see it. This is the message. And in the code, actually, we received the photography services. And here, for example, we can say we want the wedding ceremony. Oh, sorry, I have to send it from my phone number. All right, so now we have to wait 22 seconds. Remember that the automation is waiting 22 seconds after receiving each SMS before proceeding. I will now pause the video and resume once we receive the message. So here the automation has detected that we are still missing the email address and the number of photographers that we want to book. So we need to provide this information, and once it's provided, the agent will ask us to confirm. So let's do something. At this point, instead of providing this information, I'm going to ask a different type of question that the agent cannot reply, and you will see how the agent will escalate this conversation to a human. So here I have said, what are the payment methods that you accept? And my email is danny@danny. So here what we expect is that the agent escalates, and also that it keeps asking for the number of photographers, because this is a critical piece of info that we need for our booking, and I still have not provided. So let's see. We have to wait 22 seconds. Let me pause the video and I will get back to you once it's ready. All right, so you see it. The agent escalated the inquiry of the payment methods to a human agent, and still it keeps asking us about the number of photographers. So something very particular that you see is that this has been escalated, as you see here in the tag. So now if I try to text with my phone message, the automation will skip the incoming SMS until a person comes here and removes this tag. So actually, this is what we can do now. But in any case, let's go first to our Telegram, because here in Telegram, we should see, let me refresh. All right, so here you see the escalation message. Request escalated for client 346. Here I have removed my phone number just to protect my personal information. But message is, client asked about payment methods. Please provide details to the client. This keeps us in the loop and we can take over the conversation whenever we want. Let's now continue. I will provide the final piece of information, that is the number of photographers. I will say that I want 5 photographers. You see it here, I want 5 photographers. Now we have to wait for the automation. Actually, we can reply again. What I want to show you here is that the automation will only be run once, despite we have sent 2 messages. And now we have to wait again 22 seconds. Let's wait for it. What happened is that the automation didn't reply because we have not removed the tag. And this is what I said. Unless a human comes here and removes this tag, the automation will not be triggered. Actually, it's triggered and it's taking the remaining information, but it's not replying. So actually, if we can now remove this tag and now we send another message just to trigger the automation, you will see that the automation has properly detected the 5 photographers in the previous iteration, and it will not ask for this information again. Let me send the message now. I'll say hi. It's here. Now we have to wait. I will pause the video again. All right, and now we have the final message before confirmation. And it's, hello, I'm the photo pro assistant, blah, blah. It looks like we have all the information needed for your wedding photography. You have requested 5 photographers, wedding ceremony with 5 guests at this location. And please confirm all the details. So now the booking is ready to post. And once we confirm this application, the agent will take this booking and will post it on the different chat IDs that ideally would be groups, but in our case, it's our personal chat. So here I'm going to accept. Let's now wait. And as you see, despite sending 3 messages, we had 1 reply from our agent. And this is what gives this human touch feeling. All right, so now we received the message. I will refresh here. Your service request has been confirmed. You will receive photographer applications shortly. If you have any further questions, feel free to ask. And actually, we can now go to our Telegram. We have here the job published. The date, Sunday, there's a typo here, 3rd of August, Gracia, the starting time, the duration, photographers, and the services. And here we have a logic behind where we have computed how much we are paying for each photographer. And this way the photographers could see how much they would earn. And the wedding, 5 attendees, and here we have created a job code. All right, and that's it. This is the final job posting, and I hope it's clear what this full system is doing and how powerful it can be. And I hope you like it. Just before we leave, I want to make something clear, because if you have followed the conversation close, you'll realize that I have never provided this duration time, actually. So I've provided all the different details except duration, but the system has thought that the duration is going to be 2 hours. So what has happened here is that when we are sending an SMS, basically we're retrieving all the conversation that we have stored in Just Call. And actually, since I've been using my phone number in previous conversations, the automation has taken some information that was stored on those messages, but that actually are not in the dashboard. So if you remember when we started the demo, we deleted some messages, and actually I've been deleting a lot of messages. So this is the reason why you will see here some information that maybe you haven't seen in the demo. So the code for the system is fully open source. You will find it in the description. So play with it, modify it to your use case, and hopefully build something that is 100% reliable. Now let me know in the comments what automation challenges you are facing within your business, and this will serve me as a source of inspiration for my next videos. If you found the video valuable, give a like and subscribe, and I will keep uploading more deep dives on how to build production-ready AI systems. See you in the next one.